Okay, so now we're going to discuss fraction multiplication. What is the correct procedure for multiplying two fractions together? Again, as with all of our other arithmetic operations, be they whole number operations or operations with fractions, our goal is to convince students that the correct technique is in fact correct, to convince them why we do what we do instead of just throwing a procedure at them. So in the case of fraction multiplication, there are actually three different looking problems that are going to involve fractions. We could have a whole number multiplied by a fraction, we could have a fraction multiplied by a whole number, or we could have a fraction multiplied by a fraction. On the surface, these problems are going to look different. So even though we as teachers know that the same rule applies to all three situations, our students aren't going to recognize this straight off the bat, and they need to be shown in each case that the same rule applies. So we'll start with the whole number times a fraction case. And what we're going to do is we're just going to start with examples and then base our explanation on previous knowledge to lead us to the conclusion. So an example of whole number times a fraction might be 3 times a quarter. And our goal here is not necessarily to just get the answer of 3/4. What we want to do is we want to show students that to obtain that answer, we do the same thing in every single case. Mainly, we multiply the numerators together and we multiply the denominators together. So that's what we want to illustrate, that 3 times 1/4 is equal to 3 times 1, the fraction, with numerator 3 times 1 and the denominator 1 times 4. Again, here we're thinking of the number 3 as the fraction 3/1. Now, we can use our old interpretations of multiplication to explain this. We have seen that multiplication is repeated addition, or that was how we introduced multiplication of whole numbers. Multiplication is repeated addition. So from that perspective, we can think of 3 plus 1/4 as 1/4 added to itself 3 times. A fourth plus a fourth plus a fourth. Now, we already know how to add fractions together, especially fractions that have a common denominator. 1/4 plus 1/4 plus 1/4 is your 3/4. So at this stage, we do see that the answer is 3/4. We can also see that the numerator is going to be 3 times 1 because we have 3 fractions that have a numerator of 1. So in the case where we have a whole number multiplied by a fraction, it's not too difficult to illustrate the correct technique of fraction multiplication because we can use what we already know about whole number multiplication. Now, unfortunately, that changes when we move to the next case, which is a fraction multiplied by a whole number. So an example of a fraction multiplied by a whole number, we could just use 1/4 times 3. And again, in this case, our goal is to illustrate that 1/4 multiplied by 3 is again 3/4, but we really want to connect this to 1 times 3 over 4 times 1. Here's our problem though, is how are we going to interpret 1/4 times 3? Repeated addition does not work anymore, right? Because while 3 times 1/4 was simply 1/4 added to itself 3 times, 1/4 times 3 would have the interpretation 3 added to itself 1/4 times. And we can't make any sense out of that. Nor can we make sense out of maybe a set model interpretation where we would say 1/4 times 3 is 1/4 groups of 3. That doesn't really make any sense. From a measurement interpretation, we might say 1/4 times 3 is the same as 1/4 jumps of 3 on a number line. That doesn't really make sense. And even in a rectangular array model, where we think of 1/4 times 3 as 1/4 rows of 3 objects, that doesn't make any sense either. So we come to a point where we really can't interpret 1/4 multiplied by 3 by any of our previous interpretations of multiplication. What that means, of course, is that we're going to need a new interpretation of multiplication to make sense of a problem like 1/4 times 3, or really any problem where our first factor is a fraction. So the new interpretation we come up with is a familiar one. We're just going to use the word of. So we are going to interpret 1/4 times 3 as 1/4 of 3. This is certainly a reasonable interpretation to make. And now that we have made it and we can all agree that it's a valid interpretation, the next question is, well, how do we represent this? Again, we still need to illustrate that 1/4 times 3 is 3/4. How are we going to illustrate that? Well, as we do in most cases where we explain arithmetic, especially fraction arithmetic, we are going to use models. Okay? So we're going to try to illustrate 1/4 of 3. Now, there is a slight difference to this model compared to all other models that we've drawn so far involving fractions. Every other time we have drawn a model for a fraction, the diagram that we've drawn, be it a circle or a rectangle or a bar, has represented the number 1. Because in every other case up until this point, the whole unit was 1. And we were talking about a fraction of 1. In this case, however, we are not talking about a fraction of 1. We are talking about a fraction of 3. So if we want to illustrate 1/4 of 3, we need to start with 3 units. If we start with 3 units, we need to recognize that each one of these units represents the number 1. Now, if we want to illustrate 1/4 of 3, well, we can do that by chopping each of these into 4 pieces. We chop each into 4 pieces. We want 1/4 of the 3. We can take 1/4 of each of these 3 pieces. Now, the difficult part of interpreting this diagram is understanding that the answer to the question 1/4 of 3 is a fraction, but it is a fraction of 1. Okay? So since 4 fractional units make 1, right? Because again, remember, our original diagram was 3 units, so each one of these represents 1 unit, and 4 fractional units makes 1. So since 4 fractional units make 1, and 3 fractional units are shaded, the answer is indeed 3/4. Because again, though, that's the significance of the numerator and denominator in a fraction. The denominator of a fraction signifies how many fractional units make the whole. The numerator signifies how many fractional units we're interested in. Again, if we look at the diagram, 1 unit is 4 fractional units. 3 total fractional units are shaded. So the actual fraction of 1 that is shaded in this diagram is in fact 3/4. Now, this is valid if we really think about it. However, in my many years of teaching college students and also in-service teachers, many, many individuals are confused by a diagram like this. And I can imagine if this many college students and adults are confused by a diagram like this, then elementary school students may possibly be confused by a diagram like this as well. The difficulty again lies in the fact that up until this point, every diagram or every model that we've drawn of a fraction, the entire model has represented the number 1. But in this case, it doesn't, and that's a hard thing to get our head around. So for this reason, it is sometimes teachers do not illustrate this, this step in the fraction multiplication process. They will not be able to just kind of gloss over the fraction times a whole number step with the understanding and with the explanation to their students that fraction multiplication will eventually, whatever rule we decide on, it's going to have to satisfy the commutative property because all of the fraction arithmetic rules need to satisfy all of the arithmetic properties that we establish for whole numbers. So fraction multiplication will end up being commutative. So since we can make some sense out of 3 times 1/4, 3 times 1/4 is quite clearly 3/4, then we can just invoke the commutative property and say that 1/4 times 3 is also 3/4 without having to resort to a complicated picture like this. Now, even though that might reduce some of the complication of a model like this, technically that is mathematically inaccurate because we're attributing features to a procedure that we haven't even defined yet. So again, it's kind of up to you as a teacher to decide how you want to handle this case. Now, the important part of this case, however, is the new interpretation that we have arrived at for fraction multiplication, which is this interpretation of the word of. And this is the way that we are going to handle the last case of fraction multiplication, which is a fraction multiplied by another fraction. Again, if we multiply a fraction by another fraction, we have the same problem that we had in the previous case, namely that none of our old interpretations make sense anymore. So if our example is 3/4 multiplied by 2/5, Again, we cannot make sense of this from our previous models and interpretations of multiplication. Repeated addition doesn't make sense. Set model, measurement, rectangular array model, they do not make sense anymore. So we are going to have to rely on the interpretation that we just arrived at, and we are going to interpret this as 3/4 of 2/5. So this is what we need to draw. We need to draw a diagram that represents 3/4 of 2/5. Now, I mentioned this a couple of minutes ago, but in all of our examples where we're just talking about fractions, quote unquote, in a vacuum, not in context of anything else, really the fraction 2/5 on its own can be thought of as 2/5 of 1. We usually don't say that, but that's how we think of 2/5. 2/5 is 2/5 of 1. So this is what we want to represent, 3/4 of 2/5 of 1 in parentheses, if you will. So the first thing we want to draw is 2/5. 2/5 of 1. So now we're back to the situation where the model that we draw, the whole unit is 1 again, and we have to start by representing 2/5 of 1. Again, we can do this simply by dividing our whole unit into 5 pieces of equal size and shading 2 of them. Okay, so this is 2/5. Now, to obtain 3/4 multiplied by 2/5, we have to take 3/4 of 2/5. Okay? Now, the 2/5 is the shaded part. So, go off camera and get my other color. I still have it. The 2/5 is the shaded part. So really, I only want 3/4 of the 2/5 of the shaded part. So I'm going to draw that. 3/4 is going to be found again by cutting in the opposite direction 4 times and shading 3 of those parts. But again, I only want to shade the stuff that's already shaded because I don't want 3/4 of the whole. I want 3/4 of 2/5. So the 3/4 of 2/5 is going to be 3 of these strips that have been already shaded. So now the part of the diagram, the portion of the diagram that has been shaded twice, represents 3/4 of 2/5. Of course, again, we could figure out what the answer is just looking at the model. There are 20 total pieces, so that means our denominator is 20, right? 20 fractional units make a whole unit, so our denominator is 20. 6 of them have been shaded twice, so we see that the answer is in fact 6/20. But really what we want to illustrate is the procedure. We want to show that 3/4 times 2/5, or 3/4 of 2/5, is equivalent to 3 times 2 divided by 4 times 5. Now clearly 6 is 3 times 2, the numerator of the answer, and the denominator of the answer 20 is certainly 4 times 5, but the procedure that we went through actually shows us where those numbers came from. Again, before I did the double shading, we had divided the whole unit into 5 pieces and shaded 2 of them. And then what we did after that is we cut everything into 4 pieces again. So if you start with 5 pieces and you cut each of those into 4 pieces, that's going to multiply the total number of pieces 5 times 4. That's where the 20 comes from. That's where the denominator comes from. But I didn't shade all of them twice, right? Of the 2 pieces that I started with that were shaded, I only shaded 3 strips of those. So that's where my numerator comes from, of starting with 2 pieces that were shaded, of each of those 2 pieces, cutting those into 3 pieces, and that's where the 6, or the 2 times 3, comes from in the numerator.